Welcome to my video on proportional relationships. So in our previous topics that we've covered in this unit, we were looking at graphing, and most of our graphs went through the origin. But there are some that didn't go through the origin. And then we talked about that there was either a number added or subtracted. We didn't look at any that were subtraction, but those can happen. So when two quantities x and y vary in such a way that one of them is a constant multiple of the other, the two quantities are proportional. So it's a multiplicative relationship. In other words, the rule can be determined by multiplying the x value by the same number to achieve the y value. Now, there are two ways to determine a proportional relationship. See if you multiplied or divided each x value by the same amount to get the corresponding y value. But remember, when we talked about a division pattern, we said we can also represent it as a multiplication by using a fraction. So remember, if the pattern is divide by 2, we can multiply by 1/2. If it's divide by 4, we can multiply by 1/4. If it's divided by 3, we can multiply by 1/3, and so on and so forth. So number 2, see if the ratio of y over x is equivalent for all the ratios. If we take each y and its corresponding x and write them as ratios and simplify them, they should all be equivalent in a proportional relationship. So let's look at example 1 here, or example A, I should say. A certain recipe calls for each serving of a recipe to have 4 teaspoons of sugar. Complete the table to show how much sugar you would need for different serving sizes. So if you look here, we know that a 1 serving is 4 teaspoons, and I already have that in the table here. And this is called a horizontal table. A lot of the ones we look at are vertical, but this is horizontal because it goes sideways. So if 1 serving is 4 teaspoons of sugar, how many would 2 servings be? Yep, 8. And how many would 3 be? 12. And how many would 4 be? 16. And how many would 5 be? 20. So for every 1 serving size, it's 4 teaspoons of sugar. So you can see a lot of patterns going on here. Okay, so we have to ask ourselves, is this a proportional relationship? So we can look at the pattern of the y's versus, we can look at the ratio of the y over x. So now, my first one is 4 over 1. Okay, my next one is 8 over 2. Can that be simplified to 4 over 1? It sure can. My next one is 12 over 3. Can that be simplified to 4 over 1? It sure can. I can divide top and bottom by 3, and I would get 4 over 1. 16 over 4. I could divide top and bottom by 4, and I would get 4 over 1. And then 20 over 5. Would I get 4 over 1? I sure would. So this is a proportional relationship. Now, to get the rule, if I can turn a fraction into a whole number, I do for the rule. And so I look at this one, 4 divided by 1 is 4, so it's 4x. And all of these, when I divide them, I would get 4. So the rule is 4 times x, or 4 times input. And look, it does work. 4 times 1 is 4. 4 times 2 is 8, 4 times 3 is 12, and 4 times 4 is 16, and 5 times 4 is 20. Okay? Now, if it's a multiplication just a multiplication pattern. I can multiply the same number each time to get the y value, then it's a proportional relationship. So let's look at example B. Matthew is 4 years older than his sister Ashley. The following table shows the relationship between their ages at given points in time. So Matthew is 4 years older than Ashley. So if Ashley is 4, that would make Matthew 8. If Ashley is 5, that would make Matthew 9. When she's 6, he is 10. When she's 7, he is 11. And when she is 11, he is 15. Now, let's look at the ratios. So we have 8 over 4, and that we could divide top and bottom by 4, and we get 2 over 1. And if we look at the next one, we have 9 over 5. Can I divide top and bottom by the same number? No. Is that the same ratio as 2 over 1? Absolutely not. And I could write the other ones, but I know right now I could write 10 over 6, 11 over 7, and 15 over 11, but I can automatically see that they're not all going to have the same ratio. So is this proportional? No. Now let's see if we can come up with a rule here. Okay? How can I get from 4 to 8, 5 to 9, 6 to 10, 7 to 11, 11 to 15 using the same rule? Hopefully you're thinking I could add 4 to each x. So you're correct. So we would write the x first. So x plus 4. Now notice this one has an ending, which means it's not going to go through the origin. And that's why this one is a proportional relationship, because it has no ending and it would go through the origin. And we'll talk a little bit more about that in our next lesson when we look at the graphs of these. Okay, letter C. Veterinarians say that 1 year of a dog's life is equivalent to 7 years of a human life. Complete the table. So the dog's age is X and the human's age is Y. So when the dog is 1, he or she would be 7 in human years. When the dog is 2, they would be 14, because if one dog year is 7 years, then 2 is 14. And 3 would be 21. And 4 would be 28. 5 would be 35. And 6 would be 42. And you can see all kinds of patterns going on here. Okay? The X's are going up by 1 and the Y's are going up by 7, because one dog year represents 7 human years. Okay, let's look at the ratios. So remember, we go Y over X, so we're going to put 7 over 1. And then the next one is 14 over 2. And I could divide top and bottom by 2, and I would get 7 over 1. So we're so far so good. 21 over 3 would be divide top and bottom by 3, and I would get 7 over 1. And 28 over 4, divide top and bottom by 4, I would get 7 over 1. And 35 over 5, I would get 7 over 1. And 42 over 6, I would get 7 over 1. So all the ratios are the same, therefore it is a proportional relationship. And when we write the rule, we can take our simplified fraction, and this one is our simplified version of all of these, and we can turn it into a whole number, because 7 divided by 1 is 7, so we write 7x. If I couldn't turn it into a whole number, then I would just leave that fraction in front of the x, and that fraction could be improper or a regular fraction. That concludes our notes on proportional relationships. I hope you have a great day.